Here's an example of a constant acceleration problem. A car can speed up with an acceleration of 6.3 meters per second squared and slow down with an acceleration of 9.1 meters per second squared. What distance is required to go from 0 to 60 meters per second and back to 0? And what is the average velocity for the trip? Okay, so we cannot use constant acceleration for the whole trip at the same time because it doesn't have constant acceleration for the whole time. But we will assume that the acceleration is constant while it's speeding up and constant while it's slowing down. So what that means is that the car will accelerate from 0 to 60 meters per second and then slow down from 60 meters per second to 0, and that each segment of that trip is constant acceleration. So we can figure out the displacement and the time for the speed up part, and we can figure out the displacement and the time for the slow down part. All right, so for speeding up, we're going to say, okay, this is constant acceleration. And we know that the initial velocity is 0, and we know that the final velocity is 60 meters per second, and we know that the acceleration is 6.3 meters per second squared. Now, I do want to be careful. I am going to make positive the forward direction, and the car is moving forward at the end of the trip, so that's a positive velocity, and the car is moving forward and speeding up the whole time, so that means we also have a positive acceleration. Because remember, if the velocity is positive and the acceleration is positive, that means we're speeding up, which is what we're doing. Okay, so we know three things, and in constant acceleration equations, if you know three, you can always find the other two. So if I want to know the time, I can use the equation v is equal to v0 plus at, and I can plug in my numbers and find out that that means 60 is equal to 0 plus 6.3 times t. So 60 divided by 6.3, the time required to speed up is 9.5238 seconds. And notice I wrote down a lot of digits because we're not done with the problem yet, and if I ever use that again, I want to have all the digits to plug into my calculator. Okay, we can also find the displacement using displacement is equal to v0 plus 1/2 at squared. And that would require us to use the time we just calculated, which is fine, but we could also just use the information that was given in the problem by using v squared is equal to v0 squared plus 2ad, and that would give us that 60 squared is equal to 2 times 6.3 times d. So we can find the distance by doing 60 squared divided by 2 times 6.3. And that gives us 285.714 meters. So that was the time and distance required to speed up. Now for slowing down, this is also constant acceleration, and we are also going to make positive the forward direction. And so my initial velocity is 60 meters per second. my final velocity is 0, and my acceleration is negative 9.1 meters per second squared. Because if the velocity and the acceleration have opposite signs, that means we're slowing down. The velocity is forward, so to slow down, I need the acceleration to be backwards, negative 9.1. Okay, so we can do the same thing. Find the time. V equals V0 plus AT. So 0 is equal to 60 plus negative 9.1 times t. So solving that, we get t is equal to 6.5934 1 seconds. And to find the distance, again, we can use v squared is equal to v0 squared plus 2ad. V squared is 0, and that's equal to 60 squared, v0 squared, plus 2 times negative 9.1 times d. So we can do the algebra and solve that. We get 60 squared divided by 2 times 9.1, and we get that the distance is 197.802 meters. Okay, now the question asks, what distance is required to go from 0 to 60 and back to 0? So the distance required is going to be the distance required to speed up plus the distance required to slow down. So that's going to be 285.714 plus 197 0.802. And so our total distance for the whole trip, let's see, A is d1 plus d2, which is equal to 483.516 meters. And now, since we are ready to answer the final question, we had 2 significant digits given in the problem, so our answer should also have 2 significant digits. This is 480 meters. All right, part B. What is the average velocity for the trip? Now, the average velocity for the trip is going to be the total distance, d1 plus d2, divided by the total time, t1 plus t2. So we're not just going to use 480 meters. We're going to use the 483.516. And our total time is 9.52381 plus 6.59341. So our total time is 16.11722. So 483.516 divided by 16.11722 is 30.000 meters per second, which is 30 meters per second, is the average velocity for the whole trip. And I guess that's not terribly surprising, given that the average velocity for the first half of the trip is 30 meters per second, and the average velocity for the second half of the trip is also 30 meters per second. So maybe it makes sense that the average velocity for the whole trip is 30 meters per second. All right, so in all of our constant acceleration problems in Physics 2211, we cannot solve it with just one step. There's always going to be at least 2 parts of the problem where you either have to do constant acceleration or just constant velocity, distance equals velocity times time. I will see you in the next video.